Welcome to the final section of Chapter 3, 6, Solving Compound Inequalities. Now, compound inequalities are two simple inequalities, which we've just been doing simple inequalities so far. So they're two simple inequalities that are combined either by the word "and" or the word "or". Now, we have either two solutions here, or two different kind of things that happen. When we have an intersection, that means the intersection is the numbers that are solutions of both inequalities. So, in order for a number to be part of the intersection, it has to work in both inequalities. In a union, we have numbers that are solutions to either inequality. So, for example, if I had a number that worked in one inequality but not in the other, it would still be part of our solution set. So we have intersection and unions, and we'll be looking at what they look like. So we're going to start out with inequalities that involve "and". So these are called "and" compound inequalities. And typically they will look like what you see here. And at first they look kind of confusing in a way, because it's like we got two things going on at once. One thing I would encourage you to do is work these one at a time. So let me get a little square here. Might take me a second to get it formatted right. We'll just make it black. Okay, so here's my black square. Alright, now I'm just going to cover up half of the compound inequality. So what I do here is this is really two different inequalities in one. Let me solve this one first. So I'm going to subtract 1, and that gives me -6 less than x, or if I rewrite it the other way so that it's easier to see, x greater than -6. Okay? Now let's move that black box over to the other side. Now we have this inequality. Okay? Now let's solve that one. Again, I'm going to subtract 1. So that gives me x less than 2. So I have x greater than -6 and x less than 2. Now you may also see it written like this, where they just put x in the middle. It's kind of like what you see here in my second line. X less than 2, x greater than -6. Okay, this is the way your book loves to write it. I would be okay if you write it like this. It's whatever makes more sense to you. Okay, now we need to graph these. So again, we're just going to graph them one at a time. Let's start with x greater than -6. So let's put -6 on a number line, and we'll put a few numbers around it here. Now we have an open circle to the right because it's greater than. Okay, then we have less than 2. Let me just start this number line over here, because that's way too many numbers, and I know you won't want to write all those. So we got -6 on here. We're just going to put -6. Okay, and it goes to the right. And we're going to put 2 on here. Now that one is less than, so it's going to go to the left. Okay? Now notice here that these arrows have a period where they're intersecting in between -6 and 2. So that area, I'm going to kind of do a little squiggly thing here. That area is where our solutions lie. Okay? All the numbers between -6 and 2 are part of the solutions to this compound inequality. Alright, I know it's a little bit confusing at first when you first hear it, but I really think once you do a couple, it'll make more sense. So let's move down to another example. And again, I encourage you to think about this one at a time. And I'm just using the black box here to kind of help you do that. So here, I need to solve this one for x. So I'm going to add 1. So then I get 3x less than or equal to 12. Then I got to divide by 3. So then I have x less than or equal to 4. So I've got that one solved. Now, let's look at the other side. I'm going to follow the same steps, you'll notice. I have to add 1, so then I get 9 less than 3x. Then I have to divide by 3, so I get 3 less than x. And notice here's my compound statement. Now sometimes this is confusing, so like I said, you can write them out separately. This actually says x greater than 3 and x less than or equal to 4. So if I put 3 and 4 on my number line, x greater than 3, so it's an open circle to the right, x less than or equal to 4, that's a closed circle to the left. Notice again, they overlap in the middle, so I'm going to shade that in. Those are my solutions. Everything between 3 and 4. Alright? Now let's look at the ones that involve or. So these are easy to spot, okay? And the reason is they have the word or in them. See this here? So if you see the word or, you know right away it's an or inequality. So here, again, I have two inequalities. This one on the left, this one on the right. I'm going to solve them each. So I'm going to subtract 8, and then I have t greater than or equal to -1. Then over here, I subtract 8, I have t less than -6. Alright, so let's graph these. I got -6 here, and it's less than -6, so that means I'm going to have an open circle to the left. And then I got -1, and it's greater than or equal to -1, so I'm going to have a closed circle to the right. Okay? Now notice here there's no overlap in the or inequality. And that's typical. That usually happens. These are called the unions. So all the numbers that are solutions of either inequality are part of our whole solution. So every number less than -6 works. Every number greater than -1 works. The only numbers that don't work are the numbers in between -6 and -1. Let's look at another one here. So again, these are easy to spot because they have the word or in them. So they're an or inequality. So here I have to divide by 4 to solve this one on the left. So I got x less than or equal to 5. Over here I divide by 3. I get x greater than 7. Sorry, I forgot to write the word or up here. We will need to write the word or. So this would be our solution here. This would be our solution down here. So now I'm going to graph. I got 5. It's x less than or equal to 5, so it's going to be a closed circle to the left. Then I have 7. Just greater than, so I have an open circle to the right. Okay, and that's what my graph would look like for the or inequalities. Now the final thing that you'll see today on your work looks like this. Okay, and we saw this back in section 1, where they give you the graph and they ask you to write the inequality shown. So here you know right away that it's going to be an OR. And how do I know that? Well, I know that because my arrows are going in opposite directions and they don't overlap. Alright, so I'm going to pick my variable. I'm just going to use x here. So I have -8. It's going to the left with a closed circle. So that must mean it's less than or equal to -8. Over here I'm at 0, and it's an open circle to the right, so that must be greater than 0. So this would be the compound inequality for that graph. And just like in section 1, you will need to draw the graphs on your homework. Let's look at another one. Now this one I know is going to be an AND inequality. The way that I know that is my solutions are overlapping in the middle. So notice here that it starts at -2 and it ends at 5. So I know I'm going to have -2 and 5. It's open on -2 and goes to the right, so that's a greater than. It's open on 5 and goes to the left, so that's less than. So this would be my AND inequality. And once again, we want to get used to writing it in this language, combining the two together so that it looks like this. Okay? So those two statements say the same thing. Alright, so those are compound inequalities. If you have any questions, if you want to see more examples, please let me know in class, and I have more examples that I can do to help you out with these. See you guys tomorrow.